that it's also an experiment. And the question that I ask myself is it really possible to generate a backend system? Now, we know that already LLMs, they do, somehow they already write code, they write full stack projects. In this case, I'm using event sourcing, and I'm using for giving the requirements a final state machine. Maybe I try to give a very quick introduction to final state machine and event sourcing and the relationship with each other. But it's better to know this knowledge before we start the video. So final state machine is a UML diagram that represents the change of state of an entity through different transitions. A transition is essentially either an event, but in this case is a command that is sent to that entity. The command is validated, and then a new state is applied to that entity. So you can see that there are essentially transition from one state to another from a trigger, which could be an event or a command, but in this case is only a command. Now, event sourcing is a way, it's a pattern for designing a business model, and we have again entities, and the state of the entity is not saved directly in the database, but it is determined by the stream of events related to that particular entity. So again, we have an intention, a command, and is received by the entity, and that entity will validate that command. And if the command is valid, then we'll publish an event. The event is the source of truth in this case, and define and says something that has happened to that entity. And now that event will be applied to the current state, and will make the state evolve. For example, here we have an elevator, and the elevator is idle, sorry, and when we push the button to call the lift, we are going to evolve the state of the elevator from free or idle to busy, in movement. Now, what's the relationship between event sourcing and final state machine? Event sourcing, we have entities, which is or aggregate, I would say, which are essentially the set of entities within the same bounded context, so that they change with a single transaction, which is different from transition. And in the final state machine, we have an entity, we have commands, we have intention, we have new states. You would see here, for example, I created 4 types of transitions. There are synchronous guarded transitions, synchronous unguarded transitions, and asynchronous unguarded and asynchronous guarded. By the way, this one should be up. Now, the guarded unguarded, the different is essentially that the unguarded is the default, is the default criteria. So no criteria, or if all the previous criteria don't match, it's the else of a else if sort of pattern. Synchronous is that it has a reply, or asynchronous doesn't have a reply. It's as simple as that. Now let's see how transition is composed. So first of all, let's say that a final state machine starts always from a initial state. In this case, is an elevator, is idle, close that. It has each transition has a from state. So when the entity is idle, close that, and it has a command, we receive a command, an intention of calling we push the button, no? We do a floor call, and now with the guard that the lift is free, then we are going to publish an event that the lift is booked, obviously. We also acknowledge the floor call, because maybe the button, it becomes from off to red, or we see the arrow coming down. And then beside the reply, now we know that the combination of the current state and the event that we produced, or we published, will evolve the state from idle to lifting movement. Okay? Here, in this DSL domain, I don't remember now. It's essentially a language to describe a final state machine. Domain specific language. I created a little bit of a BDD terms. So we have scenarios, we have an example, and we have a given when then. Okay, where given we define the background steps, in a way, not background, necessary background, but so given that the lift is on the 7th floor, when I run this transition, because it means, so when I call this command, because this transition is defined by the current state and the command, then the target state looks like this. Now, this terminology is not really good. This is quite technical, I will say. There are better wordings, but this is a proof of concept, and it's good enough, because at the end of the day, this is what I'm looking for in the platform. You can see here I wrote a set of sentences that just they say the lift is movement, and then also I just divided this as expectations. So the expectation on the state, expectation on the reply, and expectation on the event that has been published. You can tell that this scenario here is an end-to-end test, or a unit test of the entity. Similarly, there are other scenarios here, and I have essentially defined all the different change of state. Why this is important? What is good about this? The thing is, let's have a look at this project. So you see, this one is the elevator of a state machine, and we are doing in this case we are doing analysis. We are in the analysis phase of the SLDC, and we are defining the entity, but we don't write code. But then when I compile this code, I can show you if you want, but if you trust me on the now I wrote here counter generator because it was an initial feature. I had different file state machine. You can see it's connected here. I just used this one because I didn't want to create a new one. This is the code that I've generated. So I was able definitely to generate the whole entity, and sorry, here, elevated this where. Let me generate it. So if I run maven clean install, what you will see, so I can give you, so the thing is, I have to generate the entity with the command, with the transitions. I'm tired. I'm so Okay, I will show you. I will show you anyway. While it is compiling, I'll show you a little bit how this project is divided. So we have the features, which is the actual business logic, okay? And the beauty of event sourcing is really that the business logic is defined in specific ways, not in different places in the DB, in the UI, or in the interface, and so on. And okay, here there is the framework where there is the code generation, which we will maybe see later, but maybe not. And sorry, here in the QA we have few things. We have what I managed to create that sounded quite amazing to me. It was that I was able to create, based on those examples that I created here, on each transition, I could create multiple examples with multiple scenarios. And these scenarios here are actually reproduced as a unit test. And I have also a scenario builder. So in that way, developers can build their own end-to-end tests. And why this is important? This is important because with larger language models and a very structured approach, an open-ended approach to development, it is possible to let a system generate, a platform generate all the code required. So I can see that the next future, the developers' job description is going to shift more towards the architecture, where we define the final state machine. Usually in a big company, you have the architects that they create documentation based on UML diagrams like the final state machine, uses stories, there is all the analysis part. And then there are the QAs that they do test two things. One is that the requirements really do what they expect, which is part of BDD. And the other thing is that the code does implement what the requirement says. So, as I mentioned, developers will spend their time defining the requirements and testing the requirements. The other beautiful part of this is about this open-ended approach is a backend system is essentially composed by few components. There is obviously an interface component like a REST API. Then there is a service layer, which in domain-driven design, what you have is like domain-bounded contexts, and that they are isolated, and they have all the business logic there. Then you have third-party systems, which they are called, that you could have third-party systems, and you usually use the hexagonal pattern for that, so port and adapters, and then you have an orchestration layer. Here in this proof of concept, we don't have anything about the orchestration layer, except that we should know that in general, many companies already define the orchestration layer. An orchestration layer can be implemented in different ways. One way is through workflows, like it happens in many companies. And another way is to an entity, an orchestrated, an event sourced entity. And in many companies, they use final state machine to define the state of the orchestrator. Usually the orchestrator is something that it's hard it's something quite technical, I would say, because it's essentially a way how to handle distributed transactions. It is probably the least business business model like of the development. The part that is hard to describe to a customer, and not necessarily a non-technical person will be able to understand easily. However, the theory behind is that with these three components, like an orchestrator layer, business domain context that defines the business logic, um, port adapter sort of implementation to call third-party service, and an actor, an event handler essentially that reacts to an event and calls the third-party system, it is possible to define a full backend system. Obviously, there are other aspects of the backend system which are idempotency, traceability, logs, monitoring, and so on. And that part is more like about framework. You will see here that in this implementation that now is finished to generate, there is a space for that, and it is outside the not outside the generated code, but if you still, again, you have an opinionated approach to that, you can generate that code, all the boilerplate required. So let's have a look at the code that we generated. You can see here now we have the entities, and we have the sorry, no, and we have here the code generated. So let me go straight from the entity. So this is the elevator entity, okay, and maybe I should reload. No, it's okay. Now obviously this is the concrete class. It has, as I mentioned, it has an opinionated approach how it's been developed, and again, even for event sourcing, this is not the best. I would say it's just one way. It's a MVP. It can be definitely improved. The code is generated with Kotlin Poet, but okay, here is where the most of the boilerplate is. So if you're familiar with Pecco, you have a command handler and event handler that needs to be declared. Let me format it. This is one thing that I'm not familiar anymore with. Option. Okay, what's this one? Okay, so this is the command handler, and we define certain objects we will see through, but essentially for a see here you see one-to-one almost with the final state machine, from a state. So from the state idle close, you on the command set destination, and now we see this white envelope. So with this stated this command, then when the guard is this one, then okay, handle this command here. If we go here in the implementation of this, sorry. Okay, this is the implementation. Okay, this is also is a synchronous one, so it has some code that you need to be familiar with. Account Pecco, and but you see here there is the preparation of the reply. By the end of the day, you have persist the event and build the reply. Now this build the reply is the method that needs to be implemented. Okay, and essentially here now you have these methods that will build the reply based on the state that where we received and the command. Probably I should have put the entity here. But then there is also the builder of the and then for the persist build the event. Sorry, no, it's not the reply. So to build the event, is based on the state and the command. Okay. Then you will have to build the reply, which is here, and is based on the state, the command. No. Okay, this is something that needs to be improved, I would say, rather than I will put also the event, even though you can get the information from here. Okay. So you can tell this is how this works. Now there is one limit in all of this. It is that as you can see, the payloads of the commands are empty. There is no field, there is only the ID, even though we declared there. And this is because I need an LLM to define what is the payload of the commands, events, and state. And I'm working on that. This is something that we'll see later. Now there is this structure. For each command we have an envelope, okay, and we have a payload. So the payload, it contains all the business information. The envelope is something that instead will contain everything required for a framework, for example, for monitorability, traceability, idempotency, and so on. You will put things here in the envelope. And this is again an opinionated approach. But it's a nice way how to separate all of them there like this. Now let's go one moment to the QA part. The beautiful part is that in the test section here we have test suites. So you can recognize, again I need to format it, you can recognize here, does it have still an error? There is one error here. It's because I remember. Yeah, it was because there was the way it was declared for some reason. It's sort of bug, like there was a duplicated method name. Anyway, you can tell here that this is the scenario builder, and this is the representation of when a user is from ground floor, then published an event. So this description here, this is the scenario defined the final state machine. And here I have the scenario builder. When I run the transition successful folklore, I do have, so I define the command here in the test, okay, and this is the just still part of the command. Then I set the expectations for the event, for the state, that it transitioned to this new state. Oops. And for the reply, because this is synchronous. So essentially here I could run multiple transitions. Now I have already generated out of the box, and this is done without the use of any LLM. All of this is deterministic. Okay? What I cannot do without the LLM is to define the payload of the commands, events, and state. So I, by the way, I realized that there is another sort of analysis documentation that we need, which is it's called field lineage um, traceability document. Essentially, as we know, there are business information that they they are derived or generated essentially from the state, from the commands, from the events, and so on. We know this is it's like the behavior is defined how these business information are used across the different transitions. So now I will not run it, but it is possible to run it, and this is the platform so far. It's not hard from here to have also another sort of documentation, which is like probably the UML use case, where we define what are the interfaces, and it's not going to be hard at all. There are so many frameworks that already do that they do produce REST API interfaces for this. So this approach generates it takes away all the time to generate the boilerplate, but also it, because we are using event sourcing and because we are using LLMs, it really takes out from the developer's plate the code writing part. The only place where developers might need to write code is in the analysis or in generating tests. By the way, it is possible also to generate those tests where we can test the invariances of an entity by chain. There are frameworks already that they do that. And by the way, the interesting part is that with those tests, once we can validate that the code works well, then the data generated by the test, it actually can be used to train a model, and then have a final. We have the platform transform into a large language model as well, but this is a different concept. So at the moment I'm writing the part of the business information traceability lineage, and then I will integrate this information with an LLM, and there will be multiple ways again how you can do that, but there will be a workflow of calls that will help me to understand. First of all, I would ask to the LLM what are the value objects based on all this information, and what are then let's try to a sort of TDD approach for defining the payloads, because there are, again, as I said, there are multiple ways how to write that code. You can write it in a way that the task of the LLM is small, so the reasoning capability, the reasoning skills required by the LLM can be minimal, and essentially what we are doing here is we are breaking down the indeterministic input into less and less indeterministic input, till we reach a level that whatever deterministic concept we gain out of this simplification is going to be enough for generating the whole backend code. So I was already surprised that we could run, and or I can even decide that I can write from here. I decide what are the payloads as a developer, but I believe that it can be generated by the system. That's it for the moment. This is the first experiment. Thank you for listening.